Thank you, though. Yep. See it bouncing? Yeah, we're good. Okay, so today I will talk to you about how to find equations of lines, and we'll work a bunch of different kinds of problems. And then Thursday we have the review for your test, and then what happens here? Oh, actually Thursday we have what? We have a quiz and then the review for your test, right? And then next Tuesday is test 1. So the way it works is next Tuesday, the start of class, about the first half, I'll give you a quiz, and then I'll collect it and we'll talk about the answers together, all right? So the rules for the quiz are the same as for the test. You can have a sheet of notes, all right? You can have a calculator. Phones have to be put away, right? That's pretty much it, right? You can't have your notes out, can't have your book out, and stuff like that. You might wonder, well, okay, so how are you going to make the quiz? Well, what I'll probably do is look at the homework that you're, supposed to have completed, and look through there and try to see what I think would be a reasonable question on the basis of that homework. So basically, the things on the quiz will be things like we've done in class, right? What have we done? We solved linear equations, right? We solved linear inequalities, right? I think we did. He says we did. Don't do that to me. I get genuinely confused about these two classes. I sometimes forget which one I covered and which. I mean, I shouldn't tell you this. Now I've told you my weakness. I feel like we did something else. Oh, yeah. So, yes, we have talked about equations, how to solve some basic equations. We talked about sets, inequalities, interval notation. We talked about how to solve absolute value equations and also absolute value inequalities. We talked about graphs of equations, graphs of functions, and how to find the domain and the range, either from a formula or from a picture, right? And then today, we talked about linear functions, graph and slope before, and now I'm going to focus in on a bunch of how to find the equation of a line problems today, all right? So that's basically it. So, yeah, you can always take pictures if you want. Just take... So I'll start with this, kind of let's find the equation of a line that goes through the following points, 3, 6, and -2, 8. So what I usually do when I have this problem is I figure out what's the slope need to be, and then I use point slope, and that's pretty much it. Let me add a little bit more fun to it, also graph the line. So I'll start with the graphing part, actually. So I said 3, 6. For choice of scale. Let's see here. Say that that's 8. This would make that 4, so 6 is in here. So 3, 6, let's see here, I've got, so I guess I'll put 8 would be up here. So 3, 6 is somewhere in here. No, other way around. Did I? Oh, good grief. Here, I gotta fix that. 6, 3. You cannot do that. Only I am allowed to change the points to make it fit my picture. So notice, I'm sorry guys, I changed that point right there. Okay, so that, if I do that, this is 6, 3. over 6 up 3. And let's see here, minus 2, 8 would be like up here somewhere. Right, so we're looking for the line that goes something like this, right? Was that TikTok? Sound like it? They got math on the TikTok? How long are the TikTok videos? Some math professor. Sounds like foolishness. They're serious? They're serious? They're serious? Huh. I think I'll stick with the YouTube. It's fine. I'm doing okay.
You have so many subscribers. YouTube sends you a check.
I have not monetized my channel. If I did, I'm sure I could make like tens of dollars. But yeah. Yes. Well, I mean, I got 10,000 subscribers, so it's kind of like, you know. Yeah. I used to have students that would try to get me to at the end of every class to like say thanks and subscribe, but I resisted. Oh, the only way I can get famous is if I figure out a way to do math pranks. I mean, that seems like that's the word. I mean, you can grow really fast, get millions of views. You just got to be like run into somebody, like set them up, and then go, haha, division by 0, and then like walk away, you know, something like that. That's what I think about. But I don't know. But I put some thought into this, but not enough. But when I do, then I'll monetize my channel, and that's where the big money is, math pranks. All right, so oh yeah, so slope. So m, change in y over change in x, right? I mean, this slope is the rise over the run. This is just a symbol for it. Rise is change in y, run is... Listen, you do have a formula sheet, so you can write down whichever of this you find least offensive.
Oh yeah, second.
The second one for sure, yeah.
That other one looks like
The other one looks hieroglyphics. All right, so we have to look at what's y2. I'm going to say it's 8. What's y1? 3. x2 minus 2. And then minus 6. Yeah, so I heard it 8 minus 8, so I got 5 over minus 8. Of course, that's minus 5/8. Just the same, right? And then I use point slope. Point slope says you can write the equation as y equals y1 plus m times x minus x1. If you know the slope and you know a point, this is the point slope formula for a line. And I do know the slope, and I know 2 points. I can pick whichever one I like. Which one do you want me to use? I'll use this one. How about that? Wait for what? I thought I heard somebody say wait. And I mean, there you go. That's the equation of the line. Now, if I say to leave your answer in slope-intercept form, how would we leave our answer in slope-intercept form? I could add that to the instructions. Also, leave equation in slope-intercept form. Or format, if you like. So you said what to do? I do what? I just work it out, right? Distribute, yeah. I'll buy that. So what's 5 times 6? Yep, but minus minus. So I mean, yep, but the 2 minuses, right? And then how many eighths is 3? 3 is 24/8, right?
And so when you multiply, so when you distribute, you gotta just distribute the numerator with the second number, is that it? And then you keep the denominator?
Yeah, so yeah, when we have a fraction like a over b times c plus d, we do a over b times c plus a over b times d. That's the pattern. Yeah. That's just a, there was like a little defect in the board that was making it look like my equation had an extra dot in it. So yeah, this is distributive property there. I think the 3 plus 38 is 54/8. So there you go. Slope-intercept form down there. So there are two other things we often talk about with lines, which is like once you have a line, you might want to think about another line, right? There's really two other types of lines given a particular line that we think about. And so I'll draw a picture. So the one is, you might have two lines that are like this, right? You might have two lines. One is like this, and the other one's like that, right? So you guys, can you tell me what we say in my above example? What kind of lines are these? These are what? Yeah, parallel lines. Parallel lines. And I usually use the symbol like that for parallel. And how about these ones down here? I usually, yeah, perpendicular. And so I usually use a symbol like this for perpendicular. If I don't want to write perpendicular, I'll just write that symbol. If I don't want to write parallel, I write that, you know.
Is those parallel lines, is it like a way of like, doesn't mean like no solution or something like that? I forgot what parallel means.
That is true. If we think about the parallel lines representing two different equations, the fact that they never intersect speaks to the fact that there's no solution for both of those equations at once.
Okay.
Welcome to the lecture on the 17th of September. So you must be a time traveler. You're bringing us comments from the future. That's good. That's good. What's that all about? All right. Okay, so let's suppose then that we have y equals m1x plus b for this one. And for that guy, we have y equals m2x plus b2. And likewise down here, I'll say that this one is y equals to m3x plus b3. And I want this other guy to be y equals to m4x plus b4. What I want to ask you is, how is m1 and m2 related? What's that? They're on the same graph. I mean, yeah. Can you tell me how, like, if I tell you m1 is 3, what's m2? I mean, what can you say about these two lines? They have the same slope, right? So that means that m2 has to be equal to m1. So it's 3, yeah. m1 equal to m2. So in fact, if you wanted to give a definition for when two lines are parallel in the plane, you could just say two lines are parallel if they have the same slope. Now that would work for almost everything, but there's one kind of line that would fail for, right? Vertical lines don't have a defined slope, right? You could say that the slope of a vertical line is infinity. Most people would say that the slope of a vertical line is just not defined, right? How do you get, like x equals to 3 is a vertical line, right? What's its slope? It only rises, it doesn't run. So this idea of rise over run breaks down for that one. How about this? How are the M3 and M4 related? Well, M4 is equal to minus 1 over m3 is how that goes. So perpendicular lines have negative reciprocal slopes.
Can you explain how you got that?
Actually, I don't think it would be good for me to explain how I got that in here. My default tool set to describe such things is trigonometry, which is like, yeah, I think that's something that you should know, but.
I'm not good with slopes and this type of stuff. I'm not gonna lie to you.
Well, let me look at some examples of this, and that'll make more sense. So start out with an easy one. Y equals x plus 1. Right? And how about y equals x? Right? These are parallel, I think. And as you were saying, they never intersect. So there's, if you think about trying to solve, if you try to solve x plus 1 equal to x, that gives you 1 equals to 0, which means there's no solution, right? But again, that's after test 1. We're getting there. Yeah, I don't think I asked you. 2 equations and 2 unknowns is a topic that's after test 1, yes. So I'm just writing that because it's all his fault. You started it. You started it. Well, how about this? If we have here's y equals to 2x, right? Let's see if I did that right. We go 1 eraser over, and then we go 1, 2 erasers up. Looks like that's slope 2, right? Slope 2, we go 1 over, we go 2 up. 2 erasers up, 1 eraser over. See that? So indeed, this has slope 2. My claim is that if you want a perpendicular line, you want something with slope minus a half, right? So slope minus a half, I'll go through the origin to keep it simple. So if my so I'm thinking m3 equals to 2, m4 minus 1 over 2. That to get a perpendicular line, we do negative reciprocal. And if I did it right, this should go what? It should go down, it should go 2 over, right? And 1 down. So I think that's about it. And you can see that's perpendicular. So I don't want to prove it for you, but I'll give you an example that shows you that I'm, What's that?
It ain't gonna help me though. I'm telling you, I'm slow. I don't understand this. I'm telling you, I need basic math because I struggle with this in high school.
Is this like the lowest level of math we can take here? Yeah.
But see, we've been going 5 months outside of school.
Is this the lowest math class we have here?
I don't think so.
You don't think so?
I don't,
Can I get moved to that?
let us
I'm emailing this.
let us look at an example where we use this idea of parallel and perpendicular. All right. So so find line parallel to y equals to 3x plus 2, which passes through, let's say 15 comma 2. So what can we say if we know that the line we're looking for is parallel to the line y equals 3? Same slope, right? So the mystery line has slope what? 3, right. I thought you guys didn't understand this.
We understand that part. You told us already.
It's right there, and it's right there in the question. That's why we know the answer.
That's all I know.
The slope is right there, right? Well, okay, good. And now how do you find so we'd have the slope, and we know it passes through the point 15, comma 2, so what's the equation? What's the equation for the line? Now that we figured out the slope is this, and the line in question, the line goes through where? 15, 2, that was in the question, right? So what's the equation? No, 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 no. That's not going to quite do it. I mean, the way I would typically do this is I would go back and use point slope, right? So we have y is equal to y1 plus m times x minus x1. But you told me m was 3, right? And we have a point. So 2, 3, so 3x.
3x minus 45.
So plus 2 minus 45.
And 3x plus, 3x minus 43.
Uh-huh.
Is that your equation?
So there you go. Y equals to now, so what if you don't know about this point slope formula? How do you do these problems? You don't?
Whatever I answer is closest to yours, that's the one.
You could do, this is the way I used to do it. I used to say, okay, so y equals to 3x plus b, and I just don't know what b is, right? You know the slope is 3, you don't know the y-intercept, so, but we also know that the point 15 comma 2 is there, right? So I say, okay, that means that 2 is equal to 3 times 15 plus b, so that tells me that b is equal to 2 minus 45, which is minus 43. So therefore, y is equal to 3x minus 43. So that's the other way that a lot of people teach students how to do this kind of problem. So you can use the slope-intercept as your basic idea of what a line is, and always go back to that and do plug things into that if you want.
So is that one on the right, what you've been doing?
No, I usually do this in here. I
Plus, I ain't never seen the other one.
that one?
I ain't never seen the rest of it.
Yeah, I haven't done it in here, but all right, let's do another. Find line perpendicular to the line y equals to 2x plus 7. Also given, I have messed up the wording here. Find line perpendicular to the line y equals 2x plus 7. Which also goes through, I'm not fond of the wording here, but I don't feel like writing this all out again. Well, it goes through the point. You guys pick the point. What a point? Any point you want.
3, 5.
3.5 it is. All right, good. All right, so if we want the line which is perpendicular to y equals 2x plus 7, what slope do we want for the line we're looking for? Perpendicular. Negative 1 over 2. Right, so we want m is minus 1 over 2. Right, and we know that we can use x1, y1 equal to 3 comma 5, right? And so again, we can do y is equal to y1 plus m times x minus x1, which is 5 minus 1/2 times x minus 3, which we can, simplify if we want. 5 minus 1/2 x plus 3/2. What's 5 plus 3/2? 5 and 3/2? No, do not do that. We talked about this. 6 and 1/2 is even worse.
How's that work?
It's still a mixed fraction. We don't like mixed fractions. How about that's 10 halves plus 13 halves. How many halves? 5 is 10 halves, right? Yeah, 13 over 2 minus 1/2 x. There you go. That is slope-intercept form. Let's do another example. Consider the line through 1 comma 2 and 1 comma 8. Find equation of part A, parallel line through 3, 7, and then B, the perpendicular line through, I don't know, 6, 2. So what do you guys think?
So you just want us to grab these?
Well, sometimes drawing a graph is a good idea, right?
We need to see this on the graph.
That's a good idea. So if this is 1, so we got like 1, 2 is somewhere like here, right? And then 1, 8 is like up here. Huh. What line is this? Well, it is I would agree. It's parallel to the what? Parallel to the y-axis, right? This is what kind of line? This is a vertical line. So this is that special case which defies most of our usual formulas, like the point-slope formula, the 2-point formula for the line, slope-intercept. None of these are helpful, because that's not how you capture a vertical line. Like, a vertical line is not a function. The graph of the vertical line is not a function. Graph of a function. So the equation of that line is just x equals to 1, right? I mean, y goes on and x is equal to 1. That's the equation of the vertical line. So in this case, we just have to basically use like common sense to figure out the equations of the parallel line and the perpendicular line, right? So the parallel line through 3, 7, I'll make a picture of it. It's where? 3, 7's like over here somewhere, right? If it's parallel, it's also what? Yeah, well, it's the same slope as I wouldn't say that's wrong, but it has the same undefined slope, right? I mean, it's also x equals what? No. We want the equation of the line that goes through 3, 7. I will tell you the equation is like x equals to 1, but no, look back up here, see if you can figure it out. So what would the equation of this line be? 3? That's not an equation, that's just 3. X equal to 3. X equals to 3, that would be the answer here. So the slope of this and also the slope of the x equals 1, they're undefined, right? And yet, I think you can agree x equals to 3 and x equals to 1, they're parallel, right? And like the geometric idea of parallel, right? Did you guys take Euclidean geometry in high school? No? How many people actually took like the geometry where you have parallel lines, intersecting, perpendicular bisectors, 2, 3? Yeah, so that one. That kind of parallel, like you talked about in there. You got a D in that class. I didn't like that class because I love equations.
My teacher was like 90 years old. I couldn't. I ain't even playing, but 90 years old. She was old. She had
So we did part A. How about part B? What's a line which is perpendicular to a vertical line? Is a horizontal line, right? And so we want a horizontal line through 6, 2. Where is 6, 2? It's, I mean, my picture probably, I mean, it's here somewhere, right? So we want like this guy, right? What's the equation of that? The vertical lines are x equals something. Horizontal lines are y equals something. So y equals 2? 2, right. So in the case that in case somebody throws a vertical or a horizontal line at you, you don't have to go through the slope matching or the negative reciprocal thing. You just have to use common sense to write these down. That's it. So I would encourage you, if you find yourself in a problem like this, make a little picture and think through it. You can do it. Let's try this example, except this time let's not do it with a vertical line. Let's do it with something a little bit more interesting. Example 5. Let some line pass through for 10 and minus 4 minus 2. A. Find equation of parallel line that also goes through 410 And then part B, let's find the equation perpendicular line that also goes through the point 4, 10. All right, so the earlier examples we looked at before this example 4, like example 2 and 3, I think the way the problem was stated, you could just look at the equation which was given and read off the slope, right? Like I think it was 3 and it was 2, right? Here, we can't do that, right? We just know that these 2 points are on the line, right? And so you can kind of graph what's going on, and that's probably a good habit to get into, just to not get trapped by like example 4, right? So this one goes, let's see here, I don't know, -4 plus 4. So roughly speaking, it looks something like this. That's very vague, but you know, this is the graph of this line looks something like that. I should make the graph bigger somewhere else. Let me do it over here. So I said it goes -4, -2. So that's like here. And 410. It was supposed to be a line. I tried. All right. So there you go. Now we don't, the thing is I can draw the line because I can connect the dots, but I don't know what the equation of it is yet. How do I find the equation of this line? What do I do? Yeah, find slope again. So let's find slope. M of given line, right? So M is y2 minus y1 over x2 minus x1. So we've got 10 minus a minus 2 divided by 4 minus a minus 4. So that's 12 over 8, also known as what? 3/2, I think. So slope is 3/2 of the original line, and so y equals to, let's say, 10 plus 3/2 x minus 4 is the equation of the given line. So like an easier version of this problem is where I have the problem statement have that equation in it, right? Now I can go on, I can try to answer part A and B, right? How about part A? We want parallel line. Has what? M equal to what? Yeah, 3/2, right? Yeah. Now this is kind of silly, but if you have a parallel line, right, and you have a given line, and the new line also contains a point on the given line, can you think about how would you draw that? If the parallel line also has this point, 410 on it, what's this? Exactly, yes, it's the same line. So very, very silly indeed. But indeed, this also is. So I mean, that is the equation of the line in this case. To make this more exciting, I should give you a point that's not on the line. You know? Well, I mean, I might. We did that before. All it would do is just change, see if, just here, I mean, hypothetical. If instead of, if I changed, say, in the problem statement 410, if I made that go to, say, 6, 7, right? Then instead of this, I would have written y equals to 7 plus 3/2 x minus 6. And that would be the difference. And if I did that, it would have not been the same line anymore. It would have been the line that goes through 6, 7, which is like down here somewhere. Yeah. I'm sorry. I feel like I have given you a headache from this. Is it correct? Sorry. It's not my intention. B, find the equation of the perpendicular line that goes through 410. So how about the perpendicular line has m equal to minus 1 over 3/2, right? What is minus 1 over 3/2 also known as? What happens when you take the reciprocal of a fraction? Like what's 1 over 3/18? 380 seconds. There we go. I don't know what's wrong with me. 1 over 5/7, whatever. Can you simplify that? Right? So I could rewrite minus 1 over 3/2 as just minus 2 over 3. And then, okay, y equals to what? 10 minus 2/3 x minus 4 would answer the question which I asked. And I could graph that. It would be like this. Maybe I should make you guys write on the board. What's that? No, I mean, the COVID. Anyway. All right. So I thought of another example. You're excited by the example?
Yeah, let's get it. Who's gonna cook? Mass, let's go.
So my 7-year-old. he was doing his history lesson or something. We homeschool, you know, and my wife is talking to him about the Boston Tea Party, you know, and so he gets through the end of this, and he has a question. He's like, "Why was it a party?" It's like the fish don't like tea. It's like, that is a legitimate question to ask. Like, why in the world is it a Boston? Why was it a tea party? Doesn't seem like a party at all, you know? I don't know. I think this is a good question to ask. Yes, sir.
You asked at the same time every day.
I'll allow it. He's not coming back? No, he left his stuff. We're okay. Example 6. You guys are horrible. All right. So suppose I give you the equation of a line and I ask you to find the x and the y intercepts for the line. So what do we mean by x and y intercepts? Exactly. Thank you. So, poor choices of graphing here. All right, so you guys tell me. We need to find this point here and that point. All right, I heard -8. How did you know that? That's where it crosses the y-axis exactly. So b equals -8 is y-intercept, right? Now, if you wanted to think about that, as a point, what is that? What is that point? If I ask you like an ordered pair, blank, comma, blank, what would it be? Zero? 0 and -8, right? Now, if I was an unfriendly math professor, I'd say, find the point in which there is a y-intercept, and you'd write down -8, and I'd be like, no credit. That's not a point. You know, because this is the point where the y-intercept is. But I don't do that. I don't do that. That's not how I function. Because the person who writes down that -8 is the y-intercept understands the idea. And they just haven't perhaps paid attention to the nuance of my wording. But anyway, so yeah, -8 is the y-intercept, which means that the point 0, comma, -8 is that actual place where it happens. What's the x-intercept? 3. So if I plug in y equals to 3, x equals to 3, I get y equal to 0. If I put in x equal to 3, I get 9, 3 times 3, which is 9, 9 minus 8, which is 1. Actually, when it's at 3, it's like up here somewhere. I mean, 3 comma 1 is a point on the graph, but it's not the point we're interested in. Right? We want this point right here, right? Which is something comma 0, and we don't know what that. We don't know what this is yet, right? How do you find the x-intercept? the x-intercept is where it crosses the what? The x-axis. What's the equation for the x-axis? It's y equals to 0, right? So we just set 3x minus 8 equals to 0. Whatever x solves that should tell me what the x-intercept is. And so here, the x-intercept is given to me by 3x equals to 8. So I get x is equal to 8 over 3. That is the x-intercept. The x-intercept is actually at 8/3, 0. There is a formula for the line in terms of the x and the y-intercepts. I don't remember that one right offhand. I can derive it. So I'm going to misbehave. Okay. Hey, I can't do that. That's cool. Let's see here. You got to be a very particular height for that to work. Let's see here. So if I want to find the equation for a line in terms of the x-intercept and the y-intercept. So like the way I'll derive something like that, I'll just say, okay, so y equals mx plus b. And I want to find formulas for m and for b in terms of x naught and y naught. And so like I would say, okay, so y naught is equal to m times 0 plus b. So of course, not surprisingly, y naught equals to b. And I also know that 0 is mx naught plus b, but I know that b is y naught. So that tells me that m is minus y naught over x naught. So in short, y is equal to minus y naught over x naught x plus y naught. So y minus y naught is equal to minus y naught over x naught times x. So I could write that as x naught times y minus y naught equals minus y naught x. They told me not to open it, as you might expect. As you might expect. I didn't have to. Yeah, this is not particularly pretty. I remember there's a nicer form, like x-intercept, y-intercept form of a line. I haven't found it here at the moment. I thought maybe if I just throw some algebra at it, I'll find it, but this is not particularly helpful. No, I mean, not really. Maybe if I do this. Oh, here it is, x naught y plus y naught x equals x naught y naught. I could rewrite the equation like that. So here's a formula for the, so like, for example, if I had something like 3y minus 7x equals to minus 21, if you believe the math that I just did, I can tell you that the x-intercept is 3, and the y-intercept is minus 7. Yeah. Yeah, yeah. You're fine. You're fine. Like I said, as I titled this, I'm misbehaving, right? I don't really expect you to know that formula. I don't, well, I mean, if there's a question in your homework about it, then we'll circle back to it, right? But, I mean, we could actually, I think this example would be useful to work. Let's pretend we don't know the thing I just misbehaved and found out, and let's ask the question. Consider 3y minus 7x equals to 21, right? Find the x and y intercepts of the line. See, that is a reasonable question to ask you guys. So what do you do when the line is not nicely presented, when you got like numbers in front of x and y like that? If the equation for the line isn't like y equals stuff, right? If it's like the y and the x are all intertwined. And yeah, we could do that. That's one approach. Absolutely, you could do that. So you're like, you just take, you say, well, if you don't like the way it is, you know, be the change you want to see in the world, make it so, right? Right, like that. So we isolate the 3y by adding 7x to the other side, and then divide by 3. Look at this. But that's what? That's 7/3 x plus what's 21 over 3? 7. And so that's a good idea, because now you can tell me what the y-intercept is of the line, right? Right. How about the x-intercept? I feel like I broke him. We do what? We set.
Okay, so you basically gotta do that, except you just, yeah, you gotta do that, except you just.
I guess you put the 7x where the y is.
I don't want to say just do everything else like how you did that first one.
I like that a lot. She says just well, you're saying to interchange the roles of x and y, then that should give us the x. That's what you're trying to say?
We gave you a lot of time.
I know how to say it.
You guys should spend more time making fun of each other than just agreeing that you don't understand math. It's like, it's better. I much prefer it. I much prefer it when you're ridiculing each other as opposed to like agreeing as a group you can't do math, because agreeing as a group that you can't do math will become a self-fulfilling prophecy. And I do not want to see that happen. I do not want to see that happen. So by all means, ridicule each other. It's good. I think we should bring back that dunce cap. You know, it used to be like if you're the worst kid in school, you had to wear the, you know, I worked with a colleague. He went to I think a Jesuit school, and a French school, and it was actually the case. If you were like the lowest in the class, you had to wear the dummy hat. Like, and he said I was once. He told me he was once like the second dumbest, and he almost wore that hat, and it was a great motivator because he did not want to wear that hat. So it could help. I mean, we have not been using shame in schooling for like about, I don't know, 4 decades now. Did it work?
I don't believe that. My teachers believe in shame.
Your teachers believed in shame?
Yes.
All right, well,
But the word ain't gonna answer.
all right. But we could do what you said. We could solve for x, or we could put y equal to 0. What do you want me to do? Solve for x? Okay.